branches, the branches in the dentinal tubules, going from one dentinal tubule to the next, would be a canaliculus, just like we saw in bone. So there are canaliculi, and actually the odontoblastic processes will send a branch over to the neighboring one as well. Now, whether or not there's any sort of cellular junction, I have not yet determined, not yet found in the literature. So we have those canaliculi, and we have those odontoblastic processes going through those dentinal tubules. So there's the odontoblasts there, and bear in mind, those odontoblasts, when they're right next to one another, have junctional complexes between them, gap junctions and perhaps some attachment junctions. So we have a little bit of predentin, we have those odontoblastic processes going up, and in this case it shows them going all the way out to the mantle dentin, and there's the DEJ. And we can see those canaliculi and those collaterals going from one process to the other. Now in those processes, because these cells are helping to maintain that dentin, there's going to be things like some secretory granules and also microtubules that are going to help those secretory granules go out through that odontoblastic process. So we've got those odontoblastic processes, probably not a whole lot more in the organelles within those processes, but also within that dentinal tubule, besides the odontoblastic process, there will be some fluid. And going out into the dentin, just past the predentin, will be a nerve fiber. Now in physiology, have they talked about dental pain? Okay, how about in dental anatomy? No?
Not a lot going on in that class.
Okay, well, those nerves are responsible for the sensation of pain in that dentin. And we'll come back to this in a few minutes, but there's a diagram like this in your textbook. Those nerve fibers, it has not been demonstrated that they form a synapse of any kind with the odontoblastic process. It's never been determined. So the best guess is that those nerves are stimulated by the flow of fluid up and down through that dentinal tubule. Now in high school physics, you probably made capillary tubes and dipped them in ink and watched. Anybody ever do that? Okay, one of you did. Okay, one of you watched Professor Proton when they were little. Okay, well anytime you have a capillary, fluid will flow through there rather easily. So if there's any interruption of that tubule, due to a carious lesion perhaps, or to perhaps some sort of manipulation you might be doing on the dentin, you might cause an interruption or a change in the flow of the fluid within that dentinal tubule, and that would stimulate that nerve, and then that is registered as pain. The only thing that dentin feels is pain. Doesn't matter how you stimulate that nerve, pain is the only thing that registers. And the pain is said to be exquisite. Okay, so we've got those dentinal tubules, and if we look at those in another diagram, we have a cross-section through the dental tubules, and then kind of a longitudinal section. And let me take and jiggle that slide a little bit. The film has come loose. That looks like that's not going to work. So if we look at those dentinal tubules, and we pulled out the odontoblastic process, lining the interior of each one of those tubules is a specific layer of dentin. Now we talked about mantle dentin. This is different than that. This is found all throughout the dentin. Forming this kind of sleeve in the dental tubule is something called peritubular dentin. It's right around the inside of the dental tubule. It is considered to be different. It's given a different name because it's more highly mineralized than the rest of the dentin. Not much in organic material, more calcium hydroxyapatite. That forms the peritubular dentin that we see lining those. And you can barely make this out with a good slide. In between, we have intertubular dentin. That's all of the other dentin. So intertubular dentin can be in mantle dentin, it can be in circumpulpal dentin, it can be in all the dentin, as well as the peritubular dentin. The only difference is its arrangement around the dentinal tubules. And we can see the canaliculi going between each one of those. So we've got intertubular dentin and peritubular dentin. Now the mineral content we talked about, so we have crystals of calcium hydroxyapatite, and those are found with, attached to and kind of enmeshed in the collagen that we find within the dentin. So here are a number of dentinal tubules. So this is all intertubular dentin, and the peritubular dentin is simply that dentin that surrounds the interior of the dentinal tubule. And with a little looking in the laboratory, you can find a profile something like this to see those in cross-section. Okay, so we've got the dentinal tubules, and this is a scanning electron micrograph of a dentinal tubule that has been slightly demineralized. We used a little bit of EDTA to take off the peritubular dentin. So what you're looking at is the collagen right behind that. And you can see the collagen fibers right in there. Now I have a couple of micrographs. In fact, I have two that look like the same thing, but they're stereo pairs. And I have a stereo viewer, and we'll put these up in the lab tomorrow afternoon and Thursday afternoon. And with the stereo viewer, you can see these in 3D. And you can see some of these fibers actually standing out a little bit from the background. So that's the dentinal tubule. This is actually just a ground portion of that tooth, showing the collagen fibers right there. So we have all of those collagen fibers. We did do a study on that a number of years ago, and there is no preferred orientation to any of those fibers. This is another view showing the same thing. In fact, you see the tubule going back up that way, and there's the collagen. But as you go along this entire dentinal tubule, it may look like there's a preferred orientation here, but we could not determine, at least mathematically, that there was a preferred orientation to those fibers. Okay, so we've got those dentinal tubules. So if we go back to the light microscope, that's one of the next ones. This shows a nice long collagen fiber going up and down that dentinal tubule right there. So if you go to the light microscope and look at a demineralized section of dentin, you can begin to see lines. In gross anatomy this semester, you talk about triangles. In histology, we talk about lines. We've talked about reversal lines, resting lines. Now we have the lines of von Ebner. So there's cementum, there's the PDL, and you can just barely make out the dental tubules, but you can see these rather delicate lines going up and down this way, almost at right angles to the dental tubules. These are the lines of von Ebner. These are imbrication lines, or growth lines. These are laid down periodically as the dentin is formed. And if you were to take a cross section through a tooth, they would go around the tooth like a tree ring. In fact, they're growth rings like a tree ring is a growth ring. So we see the lines of von Ebner in a demineralized section going up and down this way, just about, not quite, at right angles to the dental tubules. So we have the incremental lines of von Ebner. They're about 4 to 8 microns growth per day. And we have also some things called the lines of Owen. And we see a line of Owen right there and one right there. Lines of Owen are nothing more than thick lines of von Ebner, and that's it. Now, just like in resting lines, these things show up as being a little more basophilic because there's a little bit more protein there. It's a little bit more organic material. So the osteo or the odontoblast is laying down some dentin and it slows down, if not stops for a short time. And there's a little bit more organic material there. Then it lays down some more and it keeps on doing that. And that builds up, forms these lines of von Ebner. And if there's some sort of physiological rest or interruption, you might get a line of Owen. It's just an accentuated line of von Ebner. Now, from time to time, if you were to look at a deciduous tooth, you would see something called a neonatal line, which would be a really thick line of Owen, and that occurs when the individual is born. So, of course, you're not going to see those in every tooth. We probably will not come across a neonatal line in lab. Okay, well, those crystals of hydroxyapatite are going to be arranged with the long axis of the collagen, and the collagen that we find in the dentin is going to be more like a felt-like